So now let's go through the 5 cases that you read about. The first one is the Equifax breach in 2017. This was a breach that exposed personal data for up to 143 million customers. That's a lot of people. What's amazing about this case is that the vulnerability was discovered. It was a vulnerability in open source software. A patch was sent out to be installed with directions to install it within 2 days, and it wasn't. It wasn't installed, in fact, until 5 months later after the damage had been done. There was even a second line of defense, which is a scan that was done to see if the patches hadn't been installed. That wasn't done until a week after the vulnerability was discovered, which by itself is kind of late. And then it missed the fact that the patches hadn't been installed. So what happened is that, and this is often the case, just because there is a vulnerability, it doesn't get exploited right away because nobody who is sort of picking away at systems knows that it's there. It was 2.5 months later that finally that vulnerability was exploited and the data was stolen. And it was actually stolen in this case. It's not, sometimes it's just potentially vulnerable, but it was stolen. So this is a case which I'm kind of amazed to find it at a major financial institution, but on a smaller scale, one sees this type of thing pretty often, that there are vulnerabilities. They're almost inevitable. This gets back to the internet being an insecure mechanism in many ways. And they're discovered very often fairly quickly, and then patches are sent out, and the security doesn't depend as much on the highly skilled technical people who are discovering the vulnerabilities as on the many people who then have to apply the patches. And that's what happened or didn't happen in this case. The second case you read about, the Capital One case, is similar to the Equifax in only one regard, and that is that, again, over 100 million records were exposed. Otherwise, it's entirely different. For one part, this was a vulnerability not in the vendor's software, but in the cloud provider software. We talked earlier that, that with cloud provision comes another potential place where there might be a vulnerability. A second part is that there is actually an aspect of an inside job. You don't find that often, but it sometimes happens, where somebody within the company was able to exploit a vulnerability. But if you read about this, it's actually a highly technical vulnerability, something that's called a server-side request forgery attack. You can find it online. I'm not going to try to attempt to pretend that I really understand or am enough of an expert to teach you what that is about. But it's a vulnerability that people feel is potentially there with cloud providers unless they pay sufficient attention to it. And so I've chosen these 2 examples to illustrate that there's really a variety of ways that these major breaches can come about. And perhaps what's most distinguishing between the 2 is that one, it was the own vendor's software. Another case, it was the cloud provider software. In one case, it was what I again call stupid human tricks, people simply not doing patches when they're there. In the other case, it was actually a pretty sophisticated security vulnerability that was utilized. The next 2 cases, the IoT and the hacking of planes, are really at a very different end of the spectrum and show you what can happen with much smaller devices. We talked about IoT being another potential source of exposure these days, and that's exactly what happened with that Russian hacker case, where in that particular case, they were able to exploit vulnerabilities through printers, and the fact that whoever had set up those printers, these are web-connected devices, had left a password that said password. Now, that's a ridiculous thing to do, but when you're dealing with lots of these little devices, it's kind of human nature that you're paying less attention to these standard security issues. The problem is that they're called edge devices for a reason. They're at the edge of the network, but they can get you back into the rest of the network. So you can have a really secure network as far as the major devices, but get in through the small things. And that's exactly what happened in that case. It's actually pretty challenging to know how we're going to deal with that going forward, because it's pretty hard to devote the same level of security to every IoT device as you do to big mainframe computers. But unless we find a way to do that, we're going to have very insecure systems. The next article about hacking small planes actually, in some ways, gets us back to physical security. Think about the castle in back of me, because it talks about an instance where the vulnerability would occur if you could actually attach a physical device to a small plane that then could exploit vulnerabilities in software and hardware systems that are on that plane. So this starts feeling a little bit about like what you see in spy movies where somebody attaches a tracking device to the underside of the car. But there are instances where that's what's going on. But it's much more complex than that, because the vulnerability is because of additional devices that are parts of a lot of transportation systems that use something that's called a CAN, C-A-N bus. That stands for Controller Area Network. This is something that I only know by reading about. I'm no expert, but it was apparently developed in the 1980s and is a device that allows various microcontrollers and devices to communicate with each other, a useful thing to do. But it, again, as we learn about the internet in general, was not developed with sufficient protections for security to allow it to be invulnerable in today's context. And so that's really why people are concerned about that physical security, because that could then allow you to do things with this controller, which is itself insecure. An interesting thing that the article also mentions is that these controllers are used in automobiles as well. But there was research that alerted the automobile industry to the vulnerabilities of that. And so they've taken pretty proactive steps to overcome that, in some cases by isolating some networks from others so that you couldn't use the insecurity in one to get into some other parts. I think that last example, as well as a couple before, illustrate that security vulnerabilities tend to vary from some that are actually fairly simplistic and more about simple human things to some that are actually quite technical and require that same level of technical attention if they're not to become real vulnerabilities. The final article is about ransomware attacks. Now, I'm sure that all of you have heard about these in recent years because they've impacted quite a number of municipalities. In the United States, they've tended to impact smaller to medium-sized municipalities, and there's probably two main reasons for that. One is that those are not as likely to have the sophisticated computer security staff that, say, a large city or a state in the United States would have. But the second, and actually what was taken advantage of in some of these cases, is that they tend to outsource some of their software. That means that if somebody finds a way to break into that software, they can not only infiltrate one user, in this case, one municipality, but many of them. Interesting, in this case, it wasn't so much finding a vulnerability in the software as doing a standard malware or phishing type approach where they sent emails that allowed them to get into the software if people clicked on something, probably an attachment that they shouldn't have clicked on. So this gets back to the more simple security breaches that simply come from uneducated or not sufficiently careful users doing things that they should avoid doing. There's one other fascinating aspect to this story. I don't know if you noticed how the people who disabled the systems were paid. They were paid in Bitcoin. And what that really means is that the technology not only gave them something to break into, but a way to profit. Think of it for a second. Even if they had disabled the systems without something like Bitcoin, what would they do? They'd say, you owe me $1 million and please write a check to the following address. You know, it doesn't work. So somehow we have even made the criminals have more opportunities for success through the invention of Bitcoin, which of course was not invented with criminal intent in mind, but neither was the internet. That's in many ways the point of this whole discussion. So that concludes our 5 examples, and it's been a very varied set of examples, really just to give you a sampling and to also give you a sense of how broad the types of exploits and vulnerabilities can be. what do we take away from this on the ethical side? And what are our responsibilities as data science professionals when it comes to the security of the software that we produce? I'm sure there's many answers to that question, and I would list three things. First of all, that it's very important to think through and act upon the potential software vulnerabilities as we are producing systems. That's always been an Achilles heel of the computing software world, that there's not enough attention paid to that up front. The second one is that one needs to apply security practices diligently, especially when it's things like fixing vulnerabilities, and not only diligently, but in a timely manner. The third one that I think this last ransomware case points out is that the professionals need to educate the users, need to make users aware of ways that there are vulnerabilities that can be exploited. I'd like to wrap up with thinking a little bit about what our ethical theories might tell us, especially about the first thing I mentioned, the attention that we should pay to security issues as we're developing data science software. You could look again with any of our ethical foundations and frameworks. I'm going to think about the utilitarian one in this case. And it's really interesting to think about that. You could apply it in various ways. And let's just think about the shorter term and the longer term. If you're simply doing an analysis of, you're trying to get some software out the door in the next few months, is it worth taking a lot of extra time to make it a more ironclad piece of software as far as security vulnerabilities? It might be easy to say that the cost of that, and remember, utilitarian actually measures costs, that the cost of that is greater than the expected cost that you might have of a security breach, especially if you think that expectation is small. And that might be a valid analysis. But then if you do a longer term analysis and you think about what the costs could be if there was a significant enough breach, like the Equifax breach as an example, they can be huge. They can be huge enough to put a company out of business or cost it a decent percentage of its customers. They can even start impacting people's faith in the software industry overall. And then if you start doing that type of utilitarian calculation, perhaps it comes out on the side of putting more attention in up front. This really shows us, well, first of all, it shows us that these analyses are imperfect at best. It does remind us that we need to think not only about the near term, but about the longer term as we think about what we should put attention into in security of our software. So that wraps up the discussion of security. We're going to end this lesson with a simple short quiz, and then there will be a review and reflect lesson that comes after this, where you will do a report on a case study related to privacy and security.